Hello everyone. Today I am going to do a procedural animation system for this deer character. Now as you can see here, the character's body, the hands and the legs rotate to move properly, to adjust, align with the ground underneath. So you can see the dynamic nature of the body. So when the character is moving upward, you can see the legs are like this. They are still straight, but it is different from this animation, and like this. And when the character moving downhill, the legs are like this. See, it's like the natural way these four-leg characters' bodies behave. Let me see if I can. So as always, this episode is sponsored by these generous patrons. Thank you very much for the support you guys are giving me. Maybe you remember I previously worked on an IK system for four-legged creatures like this, but as you can see here, this doesn't look very good, especially when I try to move up like this. So I'm going to rework on this. So this is what needs to happen. So actually I got a little help from someone sent me a picture with an explanation how does the deer or any kind of animal like this works when they are going up on a hill like this. So this is the way it should happen. Actually I couldn't find the name of the person who sent this. I'm really sorry for forgetting that, because I can't find the message. I'm not sure where did he send it, in the messenger or in an email, or but I don't remember a keyword to search the person. Anyway, it has been a great help to figure this out. So yeah, let's say this guy is trying to climb up. So when he climb up, if I just rotate the room, so let's say he's going to climb up along in surface that has a angle like this in this line. So just rotating would result uh, something like this, which does not look very realistic at all. So then when in an angle, the deer try to keep the legs straight. So to do that, from the left thigh it would rotate, it would be rotated like this, and similarly from the right thigh as well, 40 degrees here, right? So okay, and similarly it would do the same for the front legs as well. To keep them straight, it will rotate him like this. So then in order to match, so using IKs and bone modifications and everything, this is the way I should move the legs of the character. And to now that you can see it is hanging on the ground, so it is floating above the ground. So to fix that, I'm gonna have to move the character, well, let's say from any of these bones, like this. So now it looks realistic, and if we want to keep the head straight also, we can use this neck bone and rotate it like this. So right now, if I make it lit, let's hide the floor, right? So if I make it like this, and let's take a screenshot. so that it will help us to find the angles. Right now, to to represent the flow, let's draw a I'm not very good with Photoshop, so bear with me. Right, let's make this small, and now let's use a line. Okay, so this is our flow. A rough sketch would be sufficient, and so let's say this angle is A. So we need a little bit of math here. So if this angle is A, I mean this angle is too thick. If this angle is A, then we should be able to calculate the angle we need to rotate from this bone and also from this one as well, using basic rules of trigonometry. So if I draw a line that is perpendicular to the flow from this thigh bone, it would be like this. Okay, and then if I draw another straight line which goes through this point, then I know that because this one is A, this one is also A. I don't remember the name of the rule, but I know that you should know that from basic mathematics. So if this one is A, then this one is a right angle. So therefore, this one is 90 minus A. So that means if I draw another line here which is perpendicular to this one is 90 minus A, small, right here, the sine degrees, alright, and that means this one is a 90-degree angle, so here it is a, right? So the rotation we should apply to the thigh bone is similar to the angle that the surface make with the horizontal plane of the world. So we should, so that's how we need to calculate the rotation we should apply to each bone. Same angle here as well. Right. So let's try to do that in Unreal then. So first I'm going to, well, let me duplicate this, and I'm gonna delete all these transform, modify, bone stuff. Let's start fresh. what's this? Oh, it's the blend space. We don't even need this, so we don't have any IK stuff going on in our blueprint. So let's delete these as well. Right, everything is deleted, and I'll delete this left over these variables as well because I don't need them. We only need the speed and the character, which I have taken like this. So we are using this speed to apply, we don't need this one to apply. Oh, my project crashed. So right, okay, let's create a new animation blueprint. So right, this is all I have now. I don't have any of the IK stuff going on, only this animation montage which used to play the animation. Okay, now this is VPA stack 1. I'll apply this animation blueprint to the character VPA stack 1. Right, now you can see when I work on these angled surfaces, nothing happens, character stays straight. So right, now let's start fixing this. So code into this. First I need to angle rotate my character to align with the surface angle. Let's add some stuff in the word. Can't I select them? Right. Okay, so this should be good enough for testing. Yeah. Right, now first to determine the angle, let's do a line trace from this bone downwards to this bone downwards, and comparing those two locations, let's determine this angle, because I can just do one line trace and get the angle of that impact as well. But if the flow is not even, that means there can be a different angle here and to the angle here. So therefore it's better to do it like that. So alright, so I already have implemented this bone trace. Oh, now let me do it again so that easier for you guys. Right, new function, trace flow. And from which bone I should trace the flow. So let's trace by channel. I'm going to use the visibility channel and debug type for duration. So start location and end location. That I'm gonna do it like this. Get the actor, get mesh, now get socket location from mesh, and I'm gonna promote the socket like this. So first I need which one? L thigh, yeah, this one. I'm gonna copy it here. So yeah, I can give it as a parameter, then use that bone as the starting location, and for the ending location at minus, let's say 200, or yeah, 200 would be enough. That's the ending location. So as the return, if it is a hit, I'm gonna return the hit, and let's break the hit result, and then I'm gonna return the location like this. Okay, now let's go to the event graph, and if we have a valid character reference, this is how I get the character reference. Get the using target phone owner, I get cast it to a character and save it to this character variable, which I did in the previous session, but it's not that hard. This is all to it. So then here trace flow, in socket name I'm going to use stack L thigh, and I'm going to do another one like this. This time I'm going to use L clavicle. Yeah, let's check if we are getting the hits correctly. Yes, right, it is working. Then what? Let's promote this to a variable. Let's call it, this is left thigh, that means left LT stands for left thigh. Left thigh hit. Okay, and yeah, let's ignore if it is going to be a hit or not for now. I'll assume we will get hit always. This one, left clavicle LC hit. Alright, now how to get angle from LT to LC? Can we use this find look at rotation from starting LT to LC. Let's print this and see. Yeah, now it's 0. Pitch and yaw, we have some value, but we don't need yaw here. What only matters is pitch and roll. Now we got some pitch value. Okay. Right. Okay, I think we can work with this. Set another part like this and another one like this, so we can check for all the angles we need. Right, still pitch. Okay, so yeah, let's go here and do a transform modify for and I'm gonna do this to the left eye. And ignore translation and rotation, add to existing. The space, I think let's try world space for now. Oh, we need to promote this to a variable. Wait, what happens if I try to move here? Do I still get pitch? Yeah, roll doesn't have anything, only pitch. Okay, so flow angle. Get the flow angle and split it, and split this one too. Connect only the pitch. Right, let's see what happens now. Okay, it's applied in the wrong way. Oh, wait. Before trying that, first I should rotate my whole character. That means I should apply this to root. Let's see. Okay, I think it works in what way? Yes. Oh, we should use world space, right? Let's see. It works when I work like this, and this way also it is fine. This way Well, I connected pitch to the roll and then add to existing in parent bonus space. So when I do that, it is like this. You can see it is inverted. So yeah, but it works in a uniform way. So that means I can let me delete this part. That means I can invert this, multiply with y minus 1 and connect. Now it should work. See? Yeah, right. Now it is working properly. Okay, and now the only thing remaining is fixing the legs. So to do that, we need to rotate these bones and these bones here with the same angle. After that, we will need to do the location fix, but let's first rotate the bones. Can we rotate them in a single no. Okay, we had to use roll because this is the x-axis and around x-axis roll, so we have to use the pitch change to rotate. Okay, so let's start with the left thigh. Oh, there. Okay. We need a transform modify bone for this as well, and bone is left thigh. So how it should work? Let's try adding the shape to the roll. We have ignored the translation and rotation. Add to existing in the parent bonus space. Let's see. Wrong. Right. Oh, wait a minute. Right. We should reset this rotation, this location offset. We should keep the character in the center to work it properly. And let's connect, break this, connect pitch to pitch, and let's see how it looks. See any difference? I'm not sure. Let's see. Well, here in the left thigh, if I go to the bonus space, it's like this. X is downwards and pitch is like this. So this one is roll. No, this one is yo, blue arrow. So I think I should connect this to the yaw in order to see, move it in the way I want, rotate it. Yeah, you can see now, but I should connect this one. Right, now you can see the effect. See, okay. So the character is trying to keep the left leg straight here, like this. So let's do the same for all 4 legs. This should be right thigh, and let's see how it acts the same way. We should apply the change to the yaw, but should it be multiplied with -1? Let's see. Right, now back legs are fine. Now let's see about the front legs. Oh wait, select left clavicle and right clavicle. Right, now it's okay. But now we need to fix the location, because you can see the legs are floating above ground somewhat. So to compensate for that, let's see. Let's see which bone we should rotate to fix that issue. Let me rotate the root. Okay, definitely I should move the root down. Is that the way to fix it? Either we have to move the root down or move the root forward. So what should we do? Well, let's try moving down first. So how do we determine the amount we should move down? Yeah, well, let's do another line trace from the character foot. But if I do that, as I rotate the character, there would be some problems as that also changing. Alright, this is the same image. So let's draw a line from here to it was previously like this, perpendicular to this flow line. Then so basically let's duplicate this. So this rotation means rotating the leg around this point like this. Okay, now how to do the calculation? This distance is same as this distance, so we can, that's a fixed one, we can check that in the model from here to leg direction, leg length. What we have to do is the this amount, this is the amount we need to calculate. So let's see if a few lines like this. So this is a right angle. So if I say, yeah, we already know this angle A, right? We have calculated that. So that means this one is also A, so this one is also A, right? And let's say this length is R. This one is R. Oh, can't I use simple here? Ah, right. If this one is R, then this blue line is R sine A, because this is a right angle and this is this angle is alpha. This length divided by R is sine A, so this length is R sine A, right? And then this angle is A, that means this angle is also A, so this length is right, this length is let's say this length is L for it. This is R sin A. And let's say this length is L. L divided by R sin A is tan A. This is also A, this angle, similar to this angle, and this is a right angle, so tan A equals L divided by R sin A. So L is R sin A tan A. So let's see, equals R sin A tan A. Cool. That's simple, right? And this part is, length of this part is R cos A. This piece. So this piece is R minus R cos A. So that means, let me draw it for you. This part is R minus R cos A. So the amount we should move downward, that means this part. That part is, that means this part. That part is, let me, L. That means R sin A cos A minus R minus, that becomes plus R cos A. Alright, I hope I'm correct. So we can further simplify this like this: R within brackets sin A cos A minus 1 plus cos A. Okay, so what's R? That means the let me reset this height from here to here. Well, let's assume R is 88. Maybe it's wrong. so slightly larger than 80, so let's say 100. We can fix that value. So here I'll add another variable, correction float value, and that needs to be calculated here. Set root correction. The equation is sin a cos a minus 1 plus cos a. We need to get the flow angle. Sin A means pitch. Sine, I think this is in degrees, yeah. And also we need cos. Sin a cos a minus 1 plus cos a. Minus 1 plus cos a and multiply it by r, so I assume it is 100. Okay, now let's go here. In the translation, let's split this and root correction. Connect here. So here translation mode add to existing and world space. Alright, it should be reverted. That means it should be multiplied by minus 100. Wait, no. Yeah, what's wrong? Let's get the absolute value here, because no matter the angle looking up or down, the root should always move down. Yeah. Then multiply this by minus 100. Right, now it is working. No. 100 is too much. Right, so I applied -50, but it is okay. But I think something is wrong with the front legs. They are not straight. Why is that? The back legs are fine though. Let's see. Does that happen because let me disable this for now. No, front leg is not rotating. Alright, let's fix it. Wait, this should be left clavicle and right clavicle. Oh, what happened there? I am pretty sure that I changed it. It's not in the way I want it to be. Oh wait, this is not connected. Did I undo it or... somewhere? I'm not sure. Maybe I undo it. I did undo it. Yeah, now it is correct. And now let's reapply the translation to existing. Right, now it should work properly. Yes, better now. Let's see over here. Okay. Well, if you don't want to do that complex calculation, we have a simpler method as well. So all we have to do is get I'll disable this for now. Do another line trace. No, trace flow for the 2 footballs. R foot. And also another one. finger. This is finger, this is foot. Okay, doesn't matter. And then add these two together. Divide by 2. So that we can get the average and get only the Z component. Oh wait, we need to get the difference here. So therefore let's get this one, drag. Oh, no need to do that. We can directly get the distance here, so we can use it. This one plus this one, divide by 2 to get the average, and then there will be some offset from the ground to this one, this bone. So I'll assume it as 10. We can change it later. So it's minus 10. And multiply this by minus 1. So there we have our own correction. But if we do it like that, we have a problem, as you can see here. See. So that's why I told you that if I use a bone for that calculation that I change, it would have a problem. So that's why we had to do it like this. So yeah, we need to stick with this. Oh wait a minute, we have done a mistake here. This is not r sin a cos a. This should be, oh, I'm really sorry, tan a. Yeah, r sin a tan a. I'm really sorry. So this should also be tan a, r sin a tan a minus 1 plus cos a. Why did that happen? Right, now we need to fix it here. Tan in degrees. Right, I'm really sorry. Let's check again. Okay, now I feel like this angle is not enough. How about 70? it's moving down a door. Right, so here is the final preview, and I'm going to stop this episode at this point. So as you can see here, the character is properly aligning with the floor. The legs and the hands rotate properly to match with the ground angle. Okay, so let me know if you have further suggestions or if I have done any mistakes on this tutorial, so we can improve the system. And thanks for watching. So as always, project files will be available through the Patreon page. You can download it there, and if you like to support my work, you can get the membership of the Patreon club. The link would be in the description below. And thanks for watching. See you in another episode. Goodbye.